Nice.
to my video. So anyway, like I said, I'm happy to be able to come here and talk about our ANTARES event broker. And thanks to Melissa for showing my slides. Glad to bring a little chaos into everybody's life today, but hey, that's what we've done for the last 6 months, right? All right, so we go to the next slide. So this past summer, we released version 1.0 of ANTARES. We actually rebuilt the system from the ground up. So it's a completely new system, but with added functionality from what we've done before. Now, our goal is to process the full LSSG stream, but we don't see ourselves as just an LSST event broker. We see ourselves as a generic time domain platform. We want to process all the alerts we can, not just LSST, and we want to keep operating after LSST stops operating. We want our system to be community driven. We want it to provide the functionality and capability that the people who use our system want to have. We want to provide tools and capabilities that they can use to do the time domain science they want to do. So right now we have a system that can do that. So if you have an algorithm or a classifier and you can turn it into a filter in our system, we'll implement it right now and you can start getting alerts from ZTF. I put the asterisk on the implemented. So the fine print is, if you give us an infinitely complex filter, we're probably not going to deploy that for you. But if you have something that's hard to do, you should talk to us and we can figure out how we can try to do that. We process the alerts in real time. It's in minutes. We don't envision any user restrictions on the use of our data products. If there are resource conflicts, we will have some kind of scientific advisory committee to provide rankings of priority for what needs to be done in case there are limitations on compute or other resources. And like I said, right now we're actively processing ZTF public alerts. You can go to the web address I show here, and we have documentation there and tutorials about how to use it, Jupyter notebooks and things like that about all the capabilities that you can take advantage of right now. So next slide. The system itself has a Kubernetes-based deployment, so we're a containerized system that we can drop into any kind of compute platform. We use Kafka streaming. That's how we get the alerts from ZTF, and then we stream out alerts in separate substreams based upon the filters that have identified things that should go, how they should be sorted. For the database technology, we have already moved to the Cassandra-based system for our real-time alert database, and it's working extremely well. It does exactly what we need it to do and can operate at scale and speed. So we've been really happy with that. And that was one of the big technology changes for our new version. The system also keeps track of the provenance on alerts. So any decision that's made, we keep track of all the which systems were in place, which algorithms were in use. So all that information is tracked with the alerts. You can always go back and reproduce what we're doing. Next slide, please. What we do to the alerts is when they enter our pipeline, we annotate them with catalogs. These are multi-wavelength catalogs. You can guess what we might have in there: Sloan, Chandra, Gaia, everything that you might imagine that is a standard catalog to have, and we're happy to add catalogs as people provide them to us. We then take the alerts that have been associated and run filters on them to try to identify or classify them. These alerts can process, these filters can process using features either from the alert itself or from the associated information. We then keep those alerts in a searchable archive. We provide watch lists. So if there's something that some object you really are interested in and an alert happens on that, we can notify you. And we can do watch lists at scale. We could have millions of items in your watch list if that's what you want. And our web portal displays the streams that we're producing. You can look at the filters, you can look at light curves, you can look at thumbnails. Well, actually, we lost some thumbnails in the transition to the new system. So so they're not there right now, but they will be as soon as we can fix that front end problem that we're working on right now. So they should be there pretty soon. You can look at the pipeline, and you can make Finder charts if you want. Next slide. As an example of some of the filters that are already in there, we can do stuff that's really simple. Just, am I near a known extragalactic source? Am I bright? Am I in Andromeda? Am I at the nucleus of a galaxy? And the Nolan solar system objects like David talked about that we ship up to the SNAPS team. But we have other things that start to get a little more involved. We have a contributed catalog from Decker French of E+A galaxies. So those, for some reason, the tidal disruption events like to take place in those galaxies. So we have a catalog of likely hosts. So if they're associated with that, you might want to look at them if they're in the nucleus. When LIGO Virgo was producing alerts, we would ingest the alert from them and then automatically generate a stream of alerts that were contained within their footprint. And we can do that for any of the multi-messenger sources. And we can implement things like the AstroRapid machine learning light curve classifier. And we're working on trying to train that better on the ZTF data as well as the LSST team. Next slide, please. So the data products that come out of ANTARES, well, there are the alerts that are annotated with the external information. We calculate features. Those filtered alerts include all the features, including the annotations, and they can be user designed. Like I mentioned before, if you can build a filter, we can implement it. We have a Jupyter-based development kit that is available on the Astro Data Lab, the science platform at the Noir Lab. You can go there right now. Here's an example of a filter. It'll show you how to build one, how to write what you want, and you submit it to us and we activate it. And we're currently in the process of redesigning the filter interface for better version control on the filters themselves. Next slide. We output our data in several ways. There's the web portal, which also has API access for everything that it provides, searches and things like that. We use the Slack channel for notifications on our watch list. So if you really want to have an alert wake you up in the middle of the night, you can configure your Slack channel to beep at you however you want. We use Kafka streams for the bulk of the data outputs, and that can be transfers of large amounts or large portions of a stream to either individual users on their own machines or to downstream brokers. And then we also have the archive of alerts that can be used for longer time period, longer analysis. Next slide, please. Here's just an image of the web portal showing how you can go there now and do searches, all the various things that it provides. The best thing to do is for you to go look at the web portal yourself and start exploring the tools that it has to offer. Next slide, please. We've been doing science ourselves with our broker. Here's a list of ATELs through, as you can see, it goes to about March. The COVID shutdowns hit us pretty heavily, but we were pretty active before then. And we've got a few papers coming out on some of the science we've been doing ourselves with it to show that yes, you can actually do that with our system. Next slide, please. One of the things we've done recently is we've been doing load tests with Google on their cloud platform to try to make sure that the system we've designed can scale to LSST rate and volume. So you can see from this figure, we were fortunate to learn that that light curve processing is linear with the number of light curve points. So that's good that it wasn't anything worse than that. And doing these tests, we learned a lot about the kind of optimizations we can do for the database and the pipeline. But with the current on-premise system that we've got, we can process 5.5 million ZTF alerts in 24 hours. And our experience with the tests on Google Cloud have shown us that our system can expand out with more CPUs and more disks and operate efficiently at the full scale. So we are confident that the ANTARES technical solution can already work at LSST scale. It just takes the money to pay for the hardware to do it. So next slide, please. So one of the things that we were asked to talk about was how the collaborations that our broker would be interested in. You know, we have connections to the various target and observation managers. You can use ANTARES through the Las Cumbres one. We're working on connections to the Sky portal. As David Turley mentioned earlier, we're working with the SNAPS group. We send them that substream. But you know, we're open to working with anybody who wants to carve out some substream and have that shipped to them. We can provide that pretty straightforward. And you know, in general, common resources are always a good idea. And so standardized APIs, standardized formats, all these things would be useful for making sure that we can all work together and make sure that we enable the most science possible. And you could also imagine common resources like an alert database or alert cutouts, things like that stored in some common way that we can all take advantage of. And so when I was thinking about this, one of the things I might suggest is that maybe we should have a broker builders summit before we have another workshop that involves the whole community, so we can get together as a group and talk about what are the standards and or formats that we're using now, and how could we work together to bring them together. So, yes, thanks. Next slide. This is actually my last slide. I just want to show you another image of our portal. Again, the web address. The best thing you can do is go look at it and see all the things that you can do with it right now. And to quote David Trilling, it exists and works. So I'm happy to take any questions now.
Great, thanks, Tom.
Yeah.
We have time for questions.
Julian Pelton asks, just out of curiosity, you're using Kafka to both collect and send the user alerts. So what is the advantage of sending gzip basin to downstream users while upstream alerts to Antares are in Avro format?
Well, we've just found that the Avro format is a little heavier weight, and also adding the annotations that we've done, it was simpler to do in a JSON format. So that's why we chose to do that. That's not necessarily baked into the system. We can convert to a different output format at will. That's just what we were using for the ZTF processing. So that's if the community wants something different, we're happy to choose something different for that.